AI agents become far more useful when Playwright MCP gives them browser control to search, click, test, and automate workflows. Let's begin with what Playwright MCP enables. Playwright MCP gives an AI agent browser control through a standard MCP connection. The agent can open a page, inspect the page structure, click buttons, type into fields, and read results. This matters because many real workflows still happen inside web apps. Instead of only explaining code, the agent can verify what the app actually does. In this tutorial, we use a local mock website so every action is safe and predictable. The goal is to understand the mechanism before using it in larger workflows. That sets up roadmap for the tutorial. First, we will understand the architecture. Then we will set up a local demo web page. Next, we will connect Playwright MCP to the AI code editor host. After that, we will ask the agent to search and click inside the local page. Then we will convert that interaction into a repeatable Playwright test. Finally, we will cover debugging, limits, and safe automation habits. With roadmap for the tutorial in mind, the next piece is the architecture before code. The AI code editor host is where the agent runs. The MCP client connects the host to external tool servers. Playwright MCP is the tool server for browser control. The browser becomes the environment the agent can inspect and act on. The local demo app gives the browser something safe to automate. Every useful action flows through this chain: agent, MCP, browser, page, result. That idea leads directly to why accessibility snapshots matter. Playwright MCP is not just screenshot-based clicking. It can expose structured page information through accessibility snapshots. That means the agent sees roles, names, and references for page elements. Buttons, inputs, headings, and labels become easier to reason about. This makes browser automation more deterministic than guessing from pixels. Good accessible machine learning improves both users and agents. Once why accessibility snapshots matter is clear, project setup becomes much easier to understand. The setup creates a small local browser automation project. Deet will serve the mock web page on localhost. Playwright test will help us turn the agent interaction into a repeatable test. The .cursor folder will hold the MCP configuration for the AI code editor host. Keeping setup small helps viewers see what each part is responsible for. This project is intentionally local and demo only. From there, the next practical step is local scripts. The package scripts define how we run and test the demo. The dev script starts the local web app on 127.0.0.1 port 5173. The test script runs Playwright tests. The headed test script opens the browser visibly for debugging. This separation is useful because the web app and tests run as different steps. The agent will automate the same local URL that the test uses later. This sets up the next important point: build the mock page. The mock page is deliberately simple. It has a heading, a labeled search input, a search button, and a result area. The label helps the agent understand which input to use. The ARIA-lib region makes the result area explicit. This is the kind of structure Playwright MCP can inspect clearly. Clean machine learning makes automation easier to explain and more reliable. Machine learning makes automation easier to explain and more reliable. That sets up add fictional demo data. The page needs predictable data for the browser test. We use one fictional company, Demo Retail Company. The record includes a simulated status, priority, and next step. This is enough to test search and result reading. The data is not connected to any real customer system. A small fixture keeps the tutorial readable on screen. With add fictional demo data in mind, the next piece is add the search behavior. The click handler turns the static page into an interactive demo. It reads the input value and compares it with the mock customer name. If it finds a match, it writes a simulated result into the page. If not, it shows a clear no result message. This gives the agent a real browser behavior to verify. The important output is visible text in the result section. That idea leads directly to run the local app. The local app must be running before the agent can automate it. The dev server serves the mock page on localhost. Open the page manually once to confirm it loads. Search for Demo Retail Company and confirm that the simulated result appears. Manual verification helps separate app bugs from MCP setup bugs. Only after this should we ask the agent to use Playwright MCP. Once run the local app is clear, connect Playwright MCP becomes much easier to understand. The MCP config tells the AI code editor host how to launch Playwright MCP. The server name is Playwright. The command is npx. The argument asks npx to run the latest Playwright MCP package. Once enabled, the host can discover browser automation tools. This is the bridge between the agent and the local browser. From there, the next practical step is what tools the agent can use. After the server starts, the agent can use browser-related tools. Typical actions include navigation, snapshots, typing, clicking, and reading page state. The agent does not need to guess from a screenshot first. It can inspect structured page information and then choose the next action. This creates a loop: inspect, act, inspect again, answer. That loop is the foundation of browser automation for AI agents. This sets up the next important point: use a constrained agent prompt. The prompt should describe the local target clearly. It should ask the agent to open the localhost page. It should give the exact demo search value. It should ask the agent to report the visible result. It should also keep the task inside the local demo page. A focused prompt makes the toolpath easier to observe and debug. That sets up expected tool call trace. A healthy run follows a clear sequence. The agent opens the local page. It takes a snapshot to understand the page structure. It fills the search field and clicks the button. It reads the updated result from the page. Then it explains the simulated result in plain English. With expected tool call trace in mind, the next piece is demo result. The final answer should reflect what the browser actually showed. For demo retail company, the result should mention an open demo ticket. It should also mention the simulated follow-up summary. The key point is that the answer comes after browser verification. The agent did not just invent a response from the prompt. It inspected the page and used the result. That idea leads directly to from agent run to test. A successful browser interaction can become a repeatable test. The agent can help draft a Playwright test from the observed workflow. The test opens the local page, fills the labeled input, clicks search, and checks the result. This is where Playwright MCP becomes useful for developers. It can help turn manual exploration into test automation. The test gives us a reusable verification artifact. Once from agent run to test is clear, generated test code becomes much easier to understand. This test captures the same local workflow. It uses the localhost URL as the target. It fills the input by its accessible label. It clicks the button by role and name. It verifies that the expected result text is visible. The test is short because the page is accessible and deterministic. From there, the next practical step is Playwright test config. The test config keeps test settings in one place. The test directory points to the tests folder. The base URL reminds us that the test target is local. Trace on first retry helps with debugging flaky failures. For this tutorial, the config stays intentionally minimal. A small config is easier to explain and maintain. This sets up the next important point: run and verify the test. After the test file exists, run the local app and the test runner. The test should open the local page and perform the same steps as the agent. A passing test confirms that the workflow is repeatable. If it fails, the failure tells us where the automation broke. This is more useful than a one-time agent demo. Repeatable tests make browser automation valuable for real development. Repeatable tests make browser automation valuable for real development. That sets up debug with headed mode. When the test fails, make the browser visible. Headed mode shows what the browser is doing step by step. The trace viewer can show page state, actions, screenshots, and timing. This helps identify wrong labels, missing elements, or unexpected text. Debug the page state before changing the prompt. Many browser automation bugs are locator or timing problems, not model problems. With debug with headed mode in mind, the next piece is common mistake: bad targets. The most common mistake is pointing the agent at the wrong target. If the local server is stopped, the page will not load. If the URL is wrong, the agent may inspect an error page. If the prompt is vague, the agent may not know the intended scope. Use exact localhost URLs in the tutorial prompt. Check the page manually before using browser automation. That idea leads directly to common mistake: poor page structure. Browser automation becomes harder when page structure is weak. Unlabeled inputs are harder to identify. Buttons with unclear names create ambiguity. Hidden or delayed results make verification harder. Good labels and roles help both users and AI agents. If the agent struggles, improve the page before writing complex prompts. Once common mistake, poor page structure is clear, safe automation boundaries becomes much easier to understand. Browser control is powerful, so boundaries matter. For learning, keep the agent on localhost. Avoid credentials, live forms, payment pages, admin pages, or private data. Use mock pages and simulated outputs first. For production, use authentication, permissions, audit logs, rate limits, and human approval. Treat browser automation as an engineering system, not a magic shortcut. From there, the next practical step is where Playwright MCP fits. Playwright MCP is best for interactive browser tasks. It helps agents explore pages, verify UI behavior, and draft tests. It is useful when page structure and state matter. It is not always the most efficient choice for every coding task. For high-throughput test generation, Playwright CLI or direct test code may also matter. Choose the tool based on the workflow, not hype. This sets up the next important point, practical use cases. A developer can use Playwright MCP to explore a local feature. A QA engineer can turn a manual flow into a draft test. A product team can validate whether a UI flow behaves as expected. A support automation prototype can test a mock portal workflow. An AI agent can inspect the browser before suggesting fixes. The strongest use cases combine browser action with verification. That sets up what not to do. Do not use tutorial agents on private accounts or production admin pages. Do not automate logins with real credentials in a demo. Do not scrape external websites without permission. Do not submit live forms or trigger real workflows. Do not treat a model-generated test as final without review. Use the local demo pattern first, then add safeguards before expanding. With what not to do in mind, the next piece is production safeguards. If this pattern moves beyond a demo, safeguards become engineering requirements. Use allow-listed domains and restricted browser profiles. Use least privilege accounts and never expose broad credentials. Log tool calls, URLs, actions, and results. Require human approval for sensitive operations. Validate generated tests before merging them into a codebase. That idea leads directly to final content recap. Playwright MCP connects an AI code editor agent to browser automation tools. The agent can inspect a page, act on elements, and verify results. A local mock web app is the safest way to learn the workflow. Accessible page structure makes automation more reliable. A successful agent run can become a repeatable Playwright test. Debugging should focus on target, page structure, locator quality, and trace output. The core pattern is simple: inspect, act, verify, then turn the workflow into a test. To wrap up, here is the key takeaway. You now have a structured overview of Playwright MCP explained, browser automation for AI agents. Review the core ideas, connect them to examples, and revisit concepts like what Playwright MCP enables, roadmap for the tutorial, the architecture before code when practicing. Subscribe to Easy Machine Learning Guide if you want to learn AI through simple explanations and real industry examples.